It's Miss Bailey with the Knox County Public Library Tutor Team, and I'm here today with another video lesson covering kindergarten and first grade academic standards. Today's standards include specific number sense standards for kindergarten and first grade. And if you look at the language of these standards, you'll notice that they don't necessarily fit the lesson exactly. Sometimes these academic standards will be standards that we are working up to or taking bits and pieces out of, highlighting them in the lesson. If you're interested in any additional grade level specific academic standards, you can visit the IDOE website that's listed right here. And before we start, whenever you see this symbol, that will mean that your learner will need these materials. Here are some notes to parents on how to modify this video lesson to best fit your learner. If you are noticing that your learner is struggling to complete these video lessons with ease, here are some suggestions that may help them work their way up to a more successful completion of the videos. Number fluency is very important. The way that I have these differentiation notes set up are the purple dots represent the level of difficulty. So one purple dot are the simpler modifications that I suggest. And back to the number fluency, here are some suggestions listed: counting in order, saying, reading, writing numbers, identifying numbers in order and out of order. It's important for all mathematicians to focus on writing numbers with correct formation. And another modification that is really important for mathematicians is, are they able to subbatize? And subbatize is when they can identify a number just by looking at the amount of objects that are representing the number without having to point and count one at a time. And you can always modify these lessons by completing the video in small increments. So some more notes to parents on how to modify these videos for your learner. I mentioned that number formation is very important for all learners. Here are some suggestions for learners who are completing the lesson pretty comfortably. So the two purple dots represent the learners who are finding that this video is a good fit for them. These learning videos are a good fit for them. Always feel free to pause and replay as much as needed. And the three purple dots represent modifications that I suggest for learners who are ready for a little bit more of a challenge. Okay, kindergartners and firsties, it's time to get started with our lesson. And before we do that, I just want to go over with you that you are all mathematicians, okay? So let's talk about what a good mathematician looks and sounds like. So good mathematicians keep their goal in mind. They use math tools, and in our last video, we talked about these math tools that you see visuals of here, a number bond. And they also use math tools to stay organized, like the 10 frame. Good mathematicians make mistakes because they try their best and they don't give up. Another thing that mathematicians need to have a lot of is good math vocabulary. So before we get started with today's lesson, let's go over some words and vocabulary, what these words mean, so that we're ready to do our very best work in today's video. So we're going to talk a lot about the word organized, and organized means when you group things together in a way that makes sense. If you are organized, you are nice and neat. Mathematicians may be organized by putting objects in rows Okay, rows again, that from review from our first math lesson, we talked about how rows go from side to side, from left to right, like we write and read. And being organized means that you put things in order. So that 10 frame here, that is a good mathematician tool to use to help you stay organized. Disorganized is the opposite of organized. Disorganized means that something may be messy, all over the place, not in order. Okay, so these cute little fish right here, they're good little fish. There's nothing wrong with how they're swimming around, but a good mathematician needs to be organized. So let's put these little fish in an organized order. So here's an example of how these little fish could be organized using our math tool, the 10 frame. Okay, I need your help. Let's organize these students. Friends, we've been out of school for a while. We're going to get back to school, and we need to remember how to get in a nice, neat line. So let's organize these students so that they are in a nice line, ready to go. We can use our 10 frame. See, look at them. They are ready to get organized. And here's what they might look like in the 10 frame to show that they're organized. Okay, some review vocabulary. In our last lesson, we talked about the word total, which also means whole amount. So here are some examples of whole amounts of things. Even though we see with the blocks, with these blocks, we have two different colors, but notice the whole amount. Okay, with the domino, we have a top and a bottom, but notice the whole amount or the total of dots. With the red and blue circles, we have two different colors of those circles, but notice the whole amount or the total of those circles. And then the circles in the 10 frame, we have some of those pretty turquoise circles in a pink circle. I want you to notice the whole amount or the total. Okay, and some of those words that we use to help describe or explain total or whole amount are all together, there are, and in all, there are. Here are some examples of how questions may be worded to you mathematicians using different wording but asking the same question. What is the whole amount? How many do you have in all? How many do you have altogether? What is the total? So even though there's different wording used there, it's asking the same question. Another review vocabulary word for you mathematicians is parts. We talked about parts in our last video lesson for math. So now that we have remembered what the whole amount is, let's look at the parts that make up these whole amounts. So looking at the blocks, the purple and red block, that stack of blocks is made up of two parts, and those two parts make up the whole amount. Same with the rest of the pictures you see here. So a whole amount, there's just one whole amount, but in the whole amount, there's more than one part. Okay, and in each of these pictures, we have two parts, more than one, making up the whole amount or total. Okay, here's an example of how a whole amount can be looked at as parts. We have three purple blocks and one red block to make up the whole stack of blocks, which are 4 in all. Okay, in our very first math lesson, we kind of looked at this math symbol, the addition sign. Math symbols are really important for mathematicians to know, to recognize when they see them, and to be able to use them themselves. So when you add, you use this addition symbol. Numbers get bigger when you add, they increase. The addition sign shows that you are adding numbers together. Looking at another math symbol, the equal sign. The equal sign shows the answer to a math problem. Okay, so equal means the same. So if I am adding 2 and 1 together, 2 plus 1, well, I would write that as 2 and then the addition sign plus 1. Equals is showing that when I have 2 and 1 added together, they equal the same thing as 3 altogether. Okay, another review word, number bond. This is a tool that we will be using today with our lesson. It's a tool to organize parts and the whole of a number. Number bonds can have all different kinds of looks. So even though these number bonds look differently from one another, they're still number bonds. And here's that tool, the 10 frame, to help us stay organized. Okay, friends, let's talk about our goal today. Now that we have warmed up all of our important mathematician vocabulary, we're ready to talk about what our big idea is for today. Today we are using math tools like that 10 frame and number bond so that we can organize our thinking. So we're really going to stay organized today. Last math lesson we were number detectives. Okay, we're still going to be number detectives today. Our goal will be achieved when we correctly identify hidden parts of a whole amount. Okay, so that's why we're using those math tools so that we can stay organized and have an easier time accomplishing our goal of correctly identifying hidden parts in a whole amount. Okay, part of organization also involves being able to use our math symbols in a number sentence. So this is a new mathematician word. An expression that is made up of numbers and math sentence. That's what a number sentence is. So just like sentences that we write and read, a math sentence just uses numbers instead of words and letters. So here we have one part. Our first part is this cute little star, 1 star, and there's a math symbol, that addition sign, plus 2 more stars, equal the same thing as that whole amount of 3. So that's what a number sentence looks like. And we're going to kind of use those today to help us organize our thinking. Okay, take a look at this picture. Do you see the whole amount? Do you see any hidden parts? I want you to see if you can imagine with your eyes, okay? So zoom in, and I want you to see if you can find a hidden part of 3 and another hidden part of 3. Okay, take a look. Can you imagine circling? Use your laser eyes to circle a hidden part of 3 and another hidden part of 3. Is that what you imagined? Okay, we organized our thinking by circling. Let's go back to that. Okay, guys, we're staying organized today. That's what good mathematicians do. So organize your thinking. You can use tools like a number bond or a 10 frame, but you can also circle the groups or the hidden parts that you see to stay organized. So our hidden parts here that we just organized by circling are 3 and 3. 3 ladybugs, 3 bumblebees. Okay, let's use the number bond to organize our thinking. So in the number bond, we can take those 3 bumblebees as a part and the 3 ladybugs as another part. And those 2 parts are going to make up that whole amount. So thinking of it using a number sentence, okay? 3 bumblebees plus 3 ladybugs equal how many bugs total? How many bugs are there total? Pause and try it on your own. Is that what you found? There are 6 bugs total. Here's another way to look at that. The parts are 3 and 3. The whole amount is 6. Okay, let's take a look at this problem. Do you see a whole amount? Do you see any hidden parts? You know what? I just noticed that I forgot to put in the symbol for materials with piece of paper and pencil. If you want to get the piece of paper and a pencil, that'd be awesome. If you want to just follow along today by answering these problems just by saying them, that's fine too. Feel free to get a piece of paper and a pencil if you want. Okay, now, again, I want you to use your spy eyes, your detective eyes, and I want you to see with this picture of these watermelon slices, can you find a hidden part of 3 and a hidden part of 4? So in your head, I want you to circle 3 watermelon slices and circle 4 watermelon slices in an organized way. Okay, if you need to pause, pause. And here's an example of how you could circle 3 watermelon slices and 4 watermelon slices to show the hidden parts in the whole amount. Okay, organize your thinking with circles. The parts are 3 and 4. Okay, let's use a number sentence to organize our thinking and our number bond. So we have 3 watermelon slices as one of the hidden parts and 4 watermelon slices as the other hidden part. So 3 watermelon slices plus 4 more watermelon slices. That would give us our whole amount. So my question to you is, how many watermelon slices are there all together? You can solve this problem by using your pencil and piece of paper, or if you want, I would go ahead and pause and answer this question. Press play when you're ready. How many watermelon slices are there all together? Let's take a look. Did you get 7? If you have a hidden part of 3 and a hidden part of 4 and you add those together, you should have a total of 7 watermelon slices. There are 7 watermelon slices all together. Another way to look at that, so here are our watermelon slices organized by circling them. The parts are 3 and 4 and the whole amount is 7. Okay, we're going to take a look at this problem. You might think, Miss Bailey, that's the same picture of watermelon slices. It is, but I want you to look at this the same problem another way. So we're going to see if we can find a different set of hidden parts. Okay, maybe you have already found another way to group these watermelon slices into circles with different hidden parts. We're being number detectives. Okay, I want you to spy with your eyes one hidden part of 1 and another hidden part of 6. Okay, can you circle with your laser eyes? See if you can find a hidden part of 1 and a hidden part of 6. Here's how I did it. So I saw this little watermelon slice kind of hanging out here by itself at the bottom, and I circled it. Remember, mathematicians can stay organized by circling. And then I saw a group of 6, so I circled those to show them as a hidden part. The parts are 1 and 6. Let's be number detectives, and let's use the number bond to organize our thinking. In one part, we have 1 watermelon slice. In the other, we have 6. And using a number sentence to organize our thinking, 1 plus 6 more watermelon slices equals how many in all? Go ahead and pause and answer this. How many watermelon slices are there in all? Press play when you're ready. Did you get 7? 1 watermelon slice plus 6 more. That means there are 7 watermelon slices in all. Okay, we just answered some questions on how to find hidden parts with these watermelon slices and the whole amount. It was the same drawing, those watermelon slices, same drawing of the watermelon slices, but we just did it 2 different ways. Let's compare. What do you notice? I'm noticing even though we have different hidden parts in each way we did this, the whole amount is the same. The whole amount is 7. Either way we did this problem. Pretty cool. And it should be the whole amount because looking at these watermelon slices, it's the same. No matter how you broke the hidden parts up, there's the same amount both ways. Okay, let's take a look at these roadblocks. Do you see the whole amount? Do you see hidden parts? I want you to be a number detective and find a hidden part that has 2 and a hidden part that has 3. Here's how I did it. I see 2 that could easily be circled and organized together, and then 3 more that could easily be circled to be organized together. Okay, let's use a number bond to organize our thinking. One part is 2 Roblox, and the other part is 3 Roblox. How many Roblox are there total? Okay, look at the number bond that we use to organize our thinking and look at the number sentence that we use to organize our thinking. 2 Roblox plus 3 Roblox. How much does that equal total? Pause and press play when you're ready. Did you find 5? There are 5 Roblox total. When we have a hidden part of 2 Roblox and a hidden part of 3 Roblox, the whole amount is 5 Roblox. Okay, here is the same problem, but we're going to look at it a different way. Take a look. Same exact picture of Roblox. They're all kind of messy and disorganized and out of order. Can you find a hidden part that has 1 and a hidden part that has 4? Okay. Look with your detective eyes, see if you can spy it, and use your laser eyes to circle those hidden parts. A hidden part that has 1 and a hidden part that has 4. Here's how I organized the Roblox. I saw this little Roblox hanging out down here by himself, so I circled him. And then the 4 at the top, I circled those together because we want our circles to be organized too. We want them to be organized and not all over the place too. Okay, we want our hidden parts to be 1 and 4. Let's use our number bond to organize our thinking. And let's use a number sentence to organize our thinking. How many Roblox are there all together? 1 Roblox plus 4 more is how many total? Did you say 5? There are 5 Roblox in all. Very good. Okay, let's compare. The first time we looked at our Roblox, we had hidden parts of 2 and 3. The second time we looked at our Roblox, we had hidden parts of 1 and 4. I want you to notice something about the whole. The whole amount is the same either way. And it should be, because no matter how we organize our hidden parts, we still have the same total amount. Okay, friends, we worked really hard today on our math skills. So we used math tools, our 10 frame, our number bond. We also used circles, and we also used number sentences so that we could organize our thinking. And our goal was to correctly identify hidden parts of a whole amount. We were number detectives again today. Great job. Friends, thank you so much for joining me today, and I hope you'll tune in again. If you need to go back and watch our video lessons for math that came before this one, then you can find those on YouTube with this link, or you can search the KCPL Tutor Team, the Knox County Public Library Tutor Team, to find those videos. You'll also find some playlists of some other really cool videos from my friends, Mr. Frederick and Mrs. Warland. So I hope to see you next time.